Welcome back. This is an Aleks training video on predicting the products of a neutralization reaction. When an acid is neutralized, it means it no longer has a very low pH. Remember, low would be 0 or 1, anything less than 7. A high pH would be anything greater than 7 up to 14. So a pH scale is from 0 to 14. So neutral is at 7. Neutralize means I'm pulling it from the edge towards the middle. So when you have an acid and a base together, several things will happen. You are going to have many times a double displacement reaction. And a double displacement reaction is when these two things break apart into charged particles, and these two things break apart into charged particles. Once they're in charged particles, they dissolve in the water, and then this is aqueous, in the water, then they can either join back together and break apart again, or they can switch partners, like a lot of precipitation reactions, and you'll see just what can happen. I'll show you. Now here I've got an acid. You can tell it's an acid because I've got a hydrogen here at the front that I can give away. Now it is a molecular bond. This is hydrogen, nitrogen, oxygen. All of these are nonmetals, and nonmetals with nonmetals are bonded molecularly. They share electrons. But something very interesting happens. There are 6 acids that are called strong acids. And strong acids does not mean that it's more corrosive than other acids. It simply means that if you put it in water, it completely breaks apart into ions. Now, this is not an ionic bond. This is not a salt. Salts always dissolve into ions when you put it in water. But strong acids will also dissolve or dissociate into ions, which means that this hydrogen, is going to lose an electron and become a hydrogen plus. And that nitrate is going to be a NO3 minus. Okay, so you're going to get a charge. It's going to act just like it were ionic. Then when you put this in water, it totally breaks apart. 100% of it breaks apart into ions. Okay, so I've got an acid here. Beside it, I've got a base, and this happens to be a strong base. Now there are 6 strong acids, and strong acids means completely breaks apart in water. There are also a number of strong bases. Okay, a little more than 6. See, I'm counting right now. 3, 4, 5, 6, 7, 8. 8 that are strong, which means that they will completely break apart into ions. Now that makes sense because this is ionic. This is an ionic bond, and when you put it together, it breaks apart completely. This hydroxide will break apart as an OH negative, and the sodium as a plus minus, or as a positive, Na positive. And you're going to essentially have the strong ones are going to be hydroxides, OHs, in groups 1 and 2. If you have these bases, now there's many bases that are not these strong ones, but these hydroxides of groups 1 and 2 will completely break apart. And so since they do, you will have something like this. H positive plus NO3 minus plus Na positive plus OH minus. Okay. Now it's already, I would have to, first of all, guess what's going to happen here. And that's what they're asking for. It says predict the products of the reaction. Okay, so this is not balanced or anything, of course, because I don't even have 2 sides yet. What would happen if I put a strong acid and a strong base together? Well, if you look at the ions that are in the water, because this is dissolved in water, these are aqueous. If the H and the NO3 come together, they'll just break apart again. If the sodium and the hydroxide come together, they'll just break apart again. So nothing will happen if they join together with what they broke apart as. But what happens if they will switch partners, like a lot of double displacement reactions will? what if this cation and this anion go together? You're going to have water. H plus OH is water. And then what are you left with? Well, you're left with a cation and an anion. This is a sodium. That's my cation. And anion is nitrate. Now this is 1 to 1, so I don't need any subscripts or parentheses or anything. So what I've done essentially, now you can do this in your head, but I broke these apart into their ions, and then realized if they come together, if these two come together, they'll just split again. If these two come back together, they'll just split again because they're both strong. They'll dissociate in water. But if you switch them out, H plus OH, this is water. And water is a liquid. Okay, water is a liquid. And then this, so this is aqueous. This is aqueous. This is a liquid, and this is aqueous. Okay, now it's not a precipitation reaction, but it works the same way. You're making water. Okay, you've got some things on both sides. You've got some nitrates on both sides. You've got some sodiums on both sides. But you're going to have essentially hydrogen and OH coming together to make water. That's your net ionic equation. And so this is how you figure it out. You're looking at this, the hydrogen from the acid, and the OH from the base will come together to make water. Then the cation from the base and the anion from the acid will come together and make a salt. So you're going to have salt plus water. Okay, now this could be balanced. I'm not sure they're asking. It just says predict the products, that is, complete the right hand of the chemical equation. Be sure your equation, so they do need me to balance it because Alex will count it wrong if it's not. So it looks like I've got sodium and sodium, that's fine. Nitrate and nitrate, that's fine. OH and H, that's fine. So in this example, it's already balanced. So I hope that helps.